In this video for lesson 4.3, we're going to cover number 10 and number 11 on page 106. In number 10 and 11, we have to determine whether the figure has rotational symmetry. If so, describe any rotations that map the figure onto itself. So if it does have rotational symmetry, we want to describe how many degrees could you rotate it so it would map onto itself. You need to remember that rotational symmetry means that a figure can be mapped onto itself by a rotation of 180 degrees or less. So basically what we're asking ourselves is, could we take this figure and rotate it enough so that it would match back onto itself completely? So for example, in number 10, to give you a visual, I took some parchment paper and I traced this figure. If I were to take this and rotate it, could I rotate it so that it would map back onto itself? And if you look, if I keep going, at this point, it looks identical to what I started with. So this first shape, this first figure, which is a regular pentagon, has 5 sides. This does have rotational symmetry. So I'm going to say yes. And I want to describe how many degrees could you rotate it until it would map back onto itself. And so to think about how many degrees you would have to rotate it, you can kind of think of this being on a graph here. And we know all the way around, rotating something all the way around a circle, so it's back onto itself, that's 360 degrees, right? Well, we know that in this regular pentagon, since there's 5 sides, if I take this point and I rotate it to here, that would map the figure back onto itself. Well, how far would I have to rotate that to make that happen? And you could think of dividing 360 degrees by 5, because there's 5 sides or 5 vertices in this regular pentagon. So you're essentially taking 360 degrees and you're dividing it into 5 equal sections. 360 divided by 5 is 72 degrees. So if I were to rotate this 72 degrees, this figure 72 degrees, it would map back onto itself. So it does have rotational symmetry with a rotation of 72 degrees. In number 11, I want to determine if this figure has rotational symmetry. Notice how all of these angles are different measures in this quadrilateral. So what that means is, in order for this to map back onto itself, I would have to rotate this all the way around 360 degrees until it matched back onto itself. So if you want a visual, I could take this and I could trace this shape onto some parchment paper. And if here was the center, let's say, I would have to rotate this. In order for it to map back onto itself, I would have to rotate this a full 360 degrees. So this does not have rotational symmetry because I can't rotate it 180 degrees or less to map it onto itself. So this figure does not have rotational symmetry.